Okay, so by now, you're probably feeling a bit sorted algorithm out. This last algorithm of the 5 is one that used in a very specific use case. And so I wanted to tell you about it because actually in that use case it's really efficient. So we use bucket sort when the data is in a known range. So imagine that I am sorting student applications by date, and I know there's only a certain number of dates they could actually come in on. In that case, with like a bucket sort algorithm, will be a really efficient way to sort that data. The bucket sort algorithm does not use comparisons, as all the other algorithms have used. Rather, the elements are inserted into indices in a data structure based on their values. Quite often, there's a very simple equation to work out where they should be inserted. After such insertions, the data structure is enumerated to obtain the data in order. So a very simple case here. I've got elements that I know are between 1 and 100, and I know there's no repeats. And so I just take 10 by 10 array, and the function I've got is whatever the number is, put it in that index. So if I've got number 15, I put it index 15 in my length 100 array. If it's 17, I put it in length 17 in my 17 array. Okay, so that's a really simple example. The other thing I could do is as if rather than taking it as a 100 continuous matrix or array, I took it as a 10 by 10 array. I could say, okay, I'm going to do an equation on this. 34. First thing I do is divide it by 10, and I see that's 3. I then do modulus arithmetic by 10 as well, and see that's 4. So I put it in index position 3, 4. So you can see that you can come up with an equation to actually work out where you should put the data. And the idea is you have an equation that tells you exactly where to put the data in the array, and then when you've put all the data in, you can just read it off in order, and it comes out sorted. So the running time of the bucket sort is the sum of the time taken to insert the elements into the data structure. So that's big O of n. Okay. Added to the time it takes to enumerate the data structure. So that's to go through the data structure. Okay. So n here is the number of elements that we're trying to sort, and m is the size of the data structure in use. Okay. So that big O of n plus m can be a really efficient way to sort, but it depends on how big that data structure is and how much of an m we have to go through. Okay. So that's the last sorting algorithm. You'll be very glad to hear, I'm sure. Again, you might want to try it out with your playing cards and see if you can get it to work. I'll be back in a minute to talk about stability of sorting and how that works.